Hello, it's Mr. Diamond, and today, instead of looking at some reactions, I'm going to talk a little bit about hybridisation of carbon, because I found this is something that quite a few students tend to have some problems with. So, as we all know, carbon, if we think back to grade 10, in our Lewis dot diagram, we draw carbon, it's 4 valence electrons like that. And that makes sense because we know that carbon pretty much exclusively forms 4 bonds. But if we now try to think about the orbital diagrams and orbital structure, carbon's electronic configuration, 6 electrons, 1s2, 2s2, 2p2, and there's an orbital diagram. We see there that carbon only has 2 unpaired electrons. So that raises the question, how are we going to get 4 bonds with just 2 unpaired electrons? And there's one theory that says, well, even though the 2p orbital is at a higher energy than the 2s, it's not much higher, and so it wouldn't take too much energy to promote one of those electrons into the vacant 2p orbital, which would now give us the 4 unpaired electrons. The problem with that is that valence bond theory tells us that bonds are formed from the overlap of an orbital on one atom with an orbital on another. And we know our 2s orbital spherical, while our 2p orbitals are more like this dumbbell shape, and we have them one there at 90 degrees and another one at 90 degrees, so both of them coming in and out of the board in the x, y and z directions. And clearly there's no way that they could form the same identical bonds as each other. The 3 p orbitals could all form identical bonds with something, but there's no way the s orbital can. And in a molecule like methane, CH4, we know that all 4 of the carbon-hydrogen bonds are identical. So we need another theory. This idea of simply promoting 1 electron just isn't going to work. In fact, if we need 4 identical bonds, then we need 4 identical orbitals. So, how do we get them? Well, as with most things in Canada, we can find the answer at Timmy's. So, if I imagine going with 3 of my friends to Tim Hortons, and we all decide we want to get a chocolate chip muffin, but when we get up to the counter, we find that they only have 3 chocolate chip muffins for sale. So either someone's going to be disappointed, or we'll have to get something else. And they do have a blueberry muffin, at least. So the 4 of us decide we'll get the 3 chocolate chip muffins and a blueberry muffin. And then somebody says, well, okay, so instead of just having somebody having to have the blueberry one, how about we cut off a quarter of each of these and replace it with 3 quarters, one each from our blueberry muffin. Now each of these muffins is 3/4 chocolate chip, 1/4 blueberry, and the one that's left, we get a quarter from each of those, and now all of a sudden we have 4 identical muffins, each of which is 1/4 blueberry, 3/4 chocolate chip, and that essentially is what we say carbon is doing. It's taken its 2s orbital, it's taken its 3 2p orbitals, and it's put them all together to make 4 identical orbitals. Because it came from the s in 3p orbitals, we call it sp3 hybridization. We started with 4 orbitals, we finished with 4 orbitals. Now each of these takes one of the valence electrons, and that gives us 4 identical orbitals, each with an electron, each able to form an identical bond with, say, hydrogen in the case of methane, and give us our molecule. So if we were to look at a slightly different molecule, instead of methane, we go to ethane. This time each carbon is forming, as we see, 2 bonds with hydrogens and the double bond between the 2 carbons. So this time we just have 3 orbitals coming together. Still the s orbital, this time only 2 of the p orbitals are involved. This is the sp2 hybridization, and 1 unhybridized p orbital is still there. This time one of our 4 people decided they didn't want to share. They keep their chocolate chip muffin to themselves, and then each of the other ones becomes essentially 1/3 blueberry to 2/3 chocolate chip. And one thing that's needs saying is that, as we know, the p orbitals are, as I said earlier, at 90 degrees to each other. We have the x, the y and the z. We need to make sure that these unhybridized orbitals are in the same orientation. So if this is a pz, then it needs to be pz on the other carbon as well, which means that these 2 that have been hybridized are from the x and the y, meaning that this would be in the xy plane, with it being a flat molecule. And we can go one step further. We go to ethyne. This time we just have 2 hybridized orbitals, the s and 1 of the p's, and this is linear, so perhaps this would be px, and then py and pz would be there to form the overlap between the 2 of them to give us our 2 pi orbitals for the triple bond. Okay, thanks for listening.